with the rich discussion on quantum computing and intelligent systems. And today we are ready to explore the next frontier of edge computing. Our first session for the evening focuses on highly impactful and emerging domain, edge computing and real-time data processing. We are honored to welcome our distinguished expert, Dr. Anup Girdharji. Dr. Anup Girdhar is a distinguished cybersecurity expert with more than 30 years of professional experience, renowned for his work in cyber crime investigations, digital forensics, and secure technology consulting. He is the CEO and founder of Security Solutions and Technologies and currently serves as editor-in-chief of Cyber Times newspaper and the Cyber Times International Journal of Technology and Management. Holding a PhD, MPhil, MCA in computer science, Dr. Girdhar has earned multiple international honors, including a patent granted national and international level in Australia for an obstacle detection model system ODMS, leveraging data mining techniques for surveillance and object identification. He has been appointed as an international trainer in cybersecurity and web architecture, delivering programs across South Africa, Nigeria, Singapore, and other countries, and has conducted training in the prestigious Hacker Halted Conference with EC Council USA. In India, he has been a resource person for World Bank funded TQIP and AICTE FTP programs and has trained professors, researchers, and professionals from premier institutions and national law enforcement agencies, including CBI, CIT, ATS, NSG, DRDO, etc. A prolific academic contributor, Dr. Girdhar has published more than 75 research papers and 50 plus technical articles, authored 25 plus books for universities including IGNOU, Tilak Maharashtra Vidyapeeth, Symbiosis, and guided numerous PhD and MTech scholars. His core area of specialization includes cybersecurity, cybercrime investigation, cyber forensic, artificial intelligence, machine learning, advanced Linux, cloud computing, and secure software development, etc. We are honored to have Dr. Girdhar with us today to share his expertise. With great respect and enthusiasm, I would now invite Dr. Anup Girdhar to kindly take this session forward and share his insightful talk with us. Sir, I would like to inform you that we have participants across different states of India. And now the virtual stage is yours. Please share your experience, sir. Thank you so much.
Great. So thank you, first of all. Thank you, Professor Neha and the entire team of WIPS for inviting me and to be a part of your one of the renowned faculty development program of ATAL. And luckily, I was associated with AICTE and this ATAL from the Pioneer project and delivered trainings to various institutions under ATAL FDPs and AICTE perspective. So thank you to AICTE and thank you to WIPS. And thank you to all the participants who are really willing at this time. Also means this is another unique culture which you have started, that you are working for the whole day and in the evening you people are again attending your FDP. So this is wonderful way. And I'm just looking that presently I think 141 people are there. So it's a great gathering and it's indeed a pleasure also for me to interact. And today, because it's related to FDP, then it is my duty and it's my part of the deliverable part that today I am taking you to something more related to live sessions, some practical oriented session. I would like to take you into, because as you said, now today we have two different things. We have to talk on edge computing as per the topic, and at the same time I have to speak because my area of expertise is more related to cyber forensic, cyber security. So I try to correlate the things and I would like to share all the researchers, all the upcoming faculties and existing professors. So today I would like to give you some another insight, the real practical insight about what are the real type of challenges, what are the real issues with the edge computing, and what are the various different types of applications, because it is a part of the kind of edge, and what is this technology all about. So we are going to talk more on it, right? Luckily, I was into the forensics, so we built some model also related to edge computing. And today, if I'm actually 7 PhDs awarded under my supervision as well. So I'm a main mentor for the 5 PhDs as a main guide, and for 2 PhDs I was a co-guide. So total 7 PhDs were awarded under my supervision, and I have seen personally the things on a technical ground. Being a guide, I'm not only a guide, I'm actually an implementer. So my scholars actually would like to connect with me because now I indulge them as well as me to do certain practicals. And I think this is what the purpose of FDP is also, because I think we will not talk only theoretical. Today you already have the concepts of AI, chat GPT, and various other models. So instead of talking that part, I will show you something live, something practicals as well. Obviously, along with the part of your some topics, at least you need to understand what is this topic all about. So we'll talk more on about the basics of topic, and then I'll take you to the practical session. So this is the way how I'm going to start my session. Let me quickly share the screen if you allow me. I hope I have the permission. Great. Yeah. Is that my screen is visible?
Yes, sir. The Zoom platform is missing.
Yeah, now it's good. It's
Yes,
Sedulity
sir.
OS.
Yes.
Perfect. Perfect. Okay. And I'll just take you to the another layer where this is edge computing and real-time data processing. So as per the topic is concerned, what is edge? First, let us try and understand what is the edge computing model. And then I'll talk about what is the real challenges about real-time data processing. And I would like to show you even with the incorporation of the forensic science, especially cyber forensic science, how we people are supposed to work on it, and what is the criteria to handle the data which is actually on the edge. But now first let us understand what is edge. Okay, I hope anybody would like to answer. Anybody know what is edge computing? Any idea about edge computing? Anybody? Or even I believe if you can go for a chat, I can read and I'll make more interactive session. So if anybody can write on chat, if they don't have a permission to unmute, that is perfectly fine. They can write on chat, I can read it through that. And even if you have any further query, they can connect and they can write on a chat. I would love to answer those queries as well. So processing a sensor level. Okay, Dr. Alka said very correctly that we are talking about processing of sensor level. Great. Professor Neha said that the data is more closer to the computing system. Perfect. Wonderful. So try and understand. I hope you heard about the concepts of cloud, right? My data is actually in the cloud. Now, even you can take it the concepts of virtualization. I hope you are already aware of what is virtualization. And in case if you are already working with the virtualization, did you ever thought of the concept like virtualized IoTs? Did you ever thought of, there is a one more concept called IIoT, that is industrial IoT devices. So think about industrial IoT devices, because why I am saying so, I have seen personally, it's been almost a decade back. I was at this Jabalpur in MP. I was at Jabalpur, and I have seen personally the smart city concept as it was implemented. And that was a time where in Delhi, even we don't have that, the speedometers deployed on the roadside to identify what is the speed of your vehicle, right? So just try and understand, even I'm talking before that. So in Jabalpur, that was a very small city sort of, where they deployed the complete e-smart city model. And I have seen 26 plus projects were running in the cinema hall sort of one of the setup, where many screens were deployed, and each project is running on each screen, and they were monitoring on the real-time basis. All the stakeholders were connected over there, and the data handling part was wonderful. Even though if you have a problem related to your municipal corporation or any other or any civil work, you can just lodge a complaint over there. They simply take it to the concerned authorities, and they'll ask frequently. I think they have some period, let's say they're in the 48 hours or 72 hours depending upon project. They decided to answer that query, about that query, and to resolve that query. That was a kind of one of the project which I have seen, and that is completely Yeah, I think it's a CM helpline also is there, and various other things which are there. Kavita, wonderful as you said, great. So please try and understand this is not a virtual concept; it is a practically implemented concept, and it's being a decade back. Today we have various other topics where we are connecting various other digital gadgets. So if I'll ask you your digital gadgets, there are, I think, even you are using a wearable, like you have a smartwatches, even you have a smart TVs. Every digital gadget is generating a data. Even not only this, these are not only the devices, but certain apps are also there. Like how many of you are on Truecaller, or why not Ola, Uber, Swiggy, Zomato? These kind of apps are also trying to grab your data. Even if you are on Google, I can show you that your day to day, every particular second, Google is actually hacking on us. They have a stalking process on us, and they keep your data permanently capturing from your devices. Even though you have a nowadays you have a CCTV camera. So what is the place where you capture the data for CCTV? Which device? What is the name of that device where you used to keep the data of CCTV footage coverage? Where you keep that data? Any idea? Anybody? What is that device called as? Do you have any idea about it? Great. Vishnuji, you are wonderful. That is one of the DVR, that is digital video recorders. Or one more another part in these days available, that is called NVR, network video recorders, which actually includes all the cameras are basically IP cameras. So there is a one more concept called NVRs and all. So think practically every single gadget is generating a data. But now what type of data are we talking about? Let's go and think about more on the detail. Let's say sensor based data, embedded systems data, IoT based data. Today you must have seen if I am not wrong, I think 15 years before I heard about Shah Rukh Khan house in Mumbai. The guys standing on the gate side, those security guards, are just working like a call center people over there. They were sitting over there. The moment anybody, on their door side, they just go and ask their details. They update those details on a walkie-talkie, and from internally, a one big iron gate was actually opened by the remotes. So basically, we are talking about sensors. We are talking about IoTs. We are talking about some industrial aspects, and why not your academic part? So let us assume I want to make your university campus, your institution, a smart campus, like any student entered to the campus, wherever that student go over there, wherever it is sitting, whatever being done by the faculties, in which postures the faculties are sitting, what the students are doing. Even though suppose you are on your job and suppose you feel sweating, and thrice or four times a day, if you are just wiping your face, shall I consider and immediately shall I able to send a doctor to you? That doctor will come, hey, you sweated today, say thrice or four times a day, are you okay? Can we think about a smart the buildings, and just try to visualize the entire system where your sensors are going to generate a data, and that data means I'm talking about even in milliseconds, the data which is generated on a millisecond. So now the concern is how to manage that data. Where is that data? I was in one of the conference in the last week only, and I met with one of very renowned person around companies, CEO and CTOs, and that is basically into the electrical equipments. Probably at your home you must be having that product of their company. So I'll not take the name, but very renowned organization who prepare these electrical appliances. You can take it like a fan, or various other electrical appliances, home appliances I'm talking about, especially home appliances. So what they said, sir, we are now, actually threatened, and we are actually looking for the security model, or we have to reframe our system, because every day we used to get 9.2 petabytes of data from the sensors. So today, probably you heard about nowadays even embedded system models are available, Raspberry Pis are available, and on that Raspberries, you can deploy some sensors and you can generate the data set from that, and through that data set, it just creates some data, it produce some data, and that has to be managed. So what would be the best framework for it, how it works, what is the criteria, and at the same time, if I want to trace the data, especially for the real time basis, how you will manage that data, what is the volume of the data, what is the latency period to process the data, where you will store the data. So these are the very common challenges coming across day by day. It was a challenge. Think about, okay, quickly I would like to show you something. If you can see my screen, I am right now on Sedulity OS. We are the India's first company. We designed the operating system, and I filed a patent somewhere in 2011. So this is one of our operating system, which is, you can say today, it's like Linux based architecture. So this is an Indian operating system, and I worked actually on the kernel level, and I guided to and I supported to our Ministry of IT, Ministry of Defense about how to customize the kernel level security and all that. So I'm actually on those grounds as well. So that is one of the way. And at the same time, you can see I just rotated my screen, and actually this is nothing. This is just a PPT, and according to you, what is this? This is just like a Windows 10. So I hope you can see this is Windows 10. No, but it is not a Windows 10. Actually, it is running in the virtualized environment. So I'm running operating system within like an application. So this is presently in my system how I'm working and how this system is performing. So I just want to show you that particular part. Okay, quickly, let me show you something more on it. Let's say I want to generate a data. Let's first of all try to calculate the data. I'll come on the presentation later on. The presentations and all, I would share the presentation if you want. That's not a purposely. But let me show you something realistic, real research work, because many faculties pan India are there, and I think they are really willing to get a real-time research. So I would like to show you something real-time research on this. So in this case, you can see I have a Windows 10 in a virtual. So two operating systems are there in my system presently working. I'll start with your CMD. I think you are the Windows user, so I'll show you even on the Windows user. I just open my CMD. On this layer, let me try to ping, say google.com. Right? Great. So I got a reply from google.com. I try to ping to google.com. I hope my screen is visible to all, right? And now it is quite, just technical part. So please make sure whatever, in case you stuck or you want to ask the answer, you can please write it down over there on the chat so that I can answer your queries at the same point of time. Now I'm going to get into a deep dive of the technical terms. Let's ping to Google. I try to ping a Google, and the moment I'll try to ping this Google, you can see by default Google, and now basically ping command. Ping command works on ICMP protocol. I think you all are aware of. So by default, the protocol is ICMP. Now, actually, I'm the person who really work more on the protocol side as well. So my various research is actually on the protocol connectivity and various other solutions and technologies which I try to incorporate in our research work. Now ping is basically ICMP protocol. It's a connectionless protocol. I think everybody know about that. The moment you generate a packet, so the generated packet is not visible on the screen. What happened at this time? My packet generated and I transferred to google.com. Google accepted my packet without any UI, user interface, or any look and feel. They accepted my packet by this particular IP address, and they responded my packets. So I got 4 reply packets. You can see 4 reply packets are there. Because there are 4 reply packets, you can see what is the size of the packet. That is always 32 bytes. Now, my question to take you towards the edge. If it is a 32 bytes, one reply 32 bytes into 4. So how many packets are there? I hope you can understand 128 bytes being generated just to get the reply. And obviously I also requested, so 128 bytes I send in the 4 different packets and I receive 4 replies. So total 8 packets generated on the network, right? Is that clear? Is that clear? Concept is clear? So there are 8 packets. Now think practically. You have a campus, a great campus, and in your campus, I want to make it a sensor-based campus. I want to deploy, let's say, 1 lakh sensors I need to deploy in your premises, and each sensor is going to generate a data on every particular second. Please take a look. The communication, the speed and communication, how much time it took to transfer the packet. Average is 6 to 7 millisecond. So see the response of the google.com about this server, about this IP. This IP, reply the packet, and my internet is also good, I would say, and that is why the reply time, the packet initiated from the Google server and I received that packet on my machine within the fraction of 7 milliseconds. Wow, wonderful. So we are talking in milliseconds, even we are not talking in seconds. My concern is if I deploy 1 lakh sensors to identify what all the activities are going on in your campus, what is the mode, at what time you came into it. I don't want touch your or biometrics or attendance like that. From the moment you enter to the campus, every student is under surveillance. Every person who is there in the campus is under a surveillance. And if anybody who tried to apply any anomaly activity, unusual behaviors, so can we go for a behavioral analysis? I hope you in AI, you know what is the anomaly detection technique. You can apply even isolation forest in AI ML. If you are into AI ML, you can try CNN, especially for classifications, or especially image classifications or video forensics, or we try to work generally on that as well. So I can show you some products and some tools if you want, and how your IoTs are working and what are the anomaly detection through IoT. I have some code also. I would love to show you that code as well. So think practically the way how it is working, right? Apart from that, now quickly I want to say, if the packet is generated in 7 milliseconds, I have 1 lakh sensors. Let us assume not in millisecond, let us assume in 1 second. If 1 lakh sensors are deployed and every sensor is generating a packet, say in 1 second, and the packet size, suppose I'll generate and use a ICMP protocol at this stage, which is, in case of Windows, it is 32 bytes. But at the same time, if you are on Linux, and again, if I do the same thing with Linux, you can see in Linux, it is by default 64 bytes. I just highlighted it is at the beginning. It is 64 bytes. So Linux generate 64 byte packet by default, and Windows generate 32 bytes packet by default. Now, if I'll say from IoT, if I'll use ICMP protocol, and I'll generate 32 bytes for every second. Can you multiply how much size of the packet is there for 1 second? 1 lakh sensors, if they'll generate 32 bytes, so it means 32 lakh bytes generated in 1 second. And this is just a one packet which I just transferred. Are you getting my point? See the size, the volume of the data. So try and understand what is the volume of the data. And if it is 32 bytes in 1 second, think about for 1 hour, think about for say couple of hours, or why not for 24/7? Don't you think so? What is the volume of the data? Can you store that level of data? Can you manage that data? Anybody can give me the answer how you will manage that data? As I told you right away, 9.2 petabytes generated in India, pan India. One of the electrical appliances company who have the IoTs, and they deployed some embedded system applications with fan, with oven, with refrigerators. This is what they have done, and they have connected with that particular part, and that sensors are generating information. If one single 32 bytes packet, let's say from one protocol like ICMP, if it's being generated, multiply by 1 lakh sensors are there to monitor, track, and then I want AI, ML, and various other activities, say for behavioral analysis, sentiment analysis, your temperature. Like, why not in case of COVID, if we had like at that time, if we had this kind of model, so the person entered to the premises, and if their body temperature is, let's say, above 98 Celsius or 100 degrees Celsius or something like that, simply that to be get monitored and traced, and medical facility to be driven to them. Think on various aspects. Your body postures. Can we predict how you generally used to sit in your office on your chair? Are you feel lazy? Are you sitting straight, or you work like this, or various different postures? So your body postures, and according to those body postures, what would be the next level of problems you might be going to face, or what type of disease might affect you because you have a behavioral process. Why not? We'll talk about your diet. We'll talk about healthcare. We'll talk about business. We'll talk about any damn thing. So think about the data with the business application that would create a problem for all of us. I hope you heard about today. That is why we are generally used to talk about the concept called big data, distributed architecture. Or earlier, probably you heard about, anybody heard about, now I have suppose 9.2 petabyte size of the data in a day. Can you store 9.2 petabyte? Anybody heard about 9.2 any petabyte hard drives? Did you ever heard about petabyte hard drives? I don't think so, right? You might heard about like 8 TB hard drive, which is quite maximum available for a regular purchase or so, right? So think about, then we have another concept. We have a RAID. We talk about redundant array integrated devices. So you can add multiple drives and you can make a RAID model which connect with the multiple devices. Probably you deploy it in NAS, network address storage. So you add multiple drives. So it is a pool of hard drives to be connected and access in a one particular drive, and then you can even increase it. Again, it is not petabyte. To create petabytes, and now again the problem is, what about, think about from the disaster recovery part as well, forensics part as well, investigation part as well, cyber security part, which if I like to incorporate in this particular part, then I need a disaster recovery site. So I actually need another concept called SAN. I hope you heard about SAN, storage area networks. So you have a concept of storage area network. So I have a multiple locations, and there I have a NAS or that kind of isolated networks for the data storage part, and I need to incorporate in one particular go so that I will get a cloud drives. Today you are talking about cloud drives and all that stuff. Do you know you can also create your own cloud drives at your home? No need to go to any cloud servers or any providers. Even you can build that, but obviously that is the volume is quite limited in that case. My concern is what, like, I would like to share a screen now in the presentation. I hope I try to sensitize the problem of and what is this edge, why edge computing is required, what is real-time data processing, and how you will handle all these stages. So quickly, I would like to show you one of the foundation of edge computing. Now think about edge. Now I want to interact with the edge to all of you. You can see my screen, I believe. There you have a cloud which is actually working for a storage and many more things. Anybody heard about the concept called fog computing? What is fog computing? So fog in the sense, let's say, I'll give you a small example. Let's say you have a different department. You have engineering, or you have IT, you have a mechanical, you have civil, or different departments. From a different stage, you have even examination department or other management departments or many other departments, legal law departments and all. So why don't I try to, if you will think about, if in your university, if I'll start creating a data and directly sending that data to the cloud, it becomes centralized. So it another way becomes a bottleneck. So the real-time problem is latency, very, very low latency to access that data, because see the volume which is coming actually towards you. Anybody watched the cricket matches? I think just a week back, and all the cricket matches were going on, and one of the match, I was sitting with my son, and he was quite fond of those match, and he was showing me that match, and it was a time where about to close, where India is about to win. That was a kind of match, and my viewpoint was not related to the match, but what I saw on Hotstar app, 25 crore users are watching that match. 25 crore users watching that match. That was on the right side top. If you can see, it was written. Can you handle 25 crore users? And where the data is not in the sensors, it's not in the 32 bytes. The size of the data is actually, with a high volume. It's in the form of frames or videos, or we need a streaming, video streamings, right? And exactly, Professor Alpana said very correctly, it is not 25 users, it is basically 25 families, 25 crore families are watching it. And again, from the various devices, probably from the mobile, from the laptop, from televisions, or any IoT, any other gadgets, right? So interoperability is again, could be one of the challenge where it is not a challenge. So how they handle that data, how Google handle this data, where it is giving you the result. I have shown you right away. The result is like in 5 milliseconds, 6 milliseconds, 7 milliseconds, and 32 bytes transferred in 7 milliseconds. Wow. So do we have some process? Think about the purpose of edge. This is preliminary. I have not even started my session. You can take it like that. This is the preliminaries, because you need to understand the purpose of edge, and then we can talk about the real-time practicals on it. So for edge, we cannot create a data from various IoTs and IIoTs gadgets, and directly we cannot go and store that data into the cloud. We need a filtration. We need a isolated areas. So fog computing is nothing. Let's say we have in India, we have four metropolitan cities: Delhi, Mumbai, Chennai, or Kolkata. Let us create 4 fog servers, and all the geospecific request to be handled by the fog servers. Let's say, can we do this? So basically what we are doing, we are trying to create a cluster and talking about load balancers, right? So we try to segregate the data size, and we are broadcasting to the fog server. So cloud is broadcasting to the fog server, and fog server is giving a data to their concern localities. As I said, in your college, you can make, for IT department, you have a different so kind of intermediaries. That's right, Professor Sandhya. So you can understand we have a various different layers. So let's say for every department in your organization, in your university, we'll try to incorporate a separate fog server. So that would be more faster than the data stores on the cloud side. But then it means we are trying to reduce the latency period, the accessibility at that same point of time. Next, even though anybody heard about so where is the edge? That is the basic foundation of the edge. But today this is not the edge. Take my words. Please take my word. This is the way how the edge was started, how it was initiated, and now this is a kind of architecture, you can say, for a top tech IT IT giants, like even why not Hotstar, or why not Google, Facebook, Twitter, LinkedIn, and all. So they have fogs and all that kind of architecture. But this is not enough. What I'm talking about, at your home, can you give me the list of the devices running at your home? I have just checked the day before yesterday. Almost 25 IP addresses allotted to my gadgets in my home only. 25 gadgets. Could be a mobile, all connected to Wi-Fi. And every device is creating a package. 25 is very less. I think today you might have more than that. All right. So think about what we all are doing. We are generating the data. So first, volume of the devices increase rapidly, right? The volume of the gadgets are increasing rapidly. We all are coming towards the internet base, and that is why we need a best internet connection. And again, 5G is about to be obsoleted, and very soon India need a 6G networks. Why 6G networks? What is the reason? Because the volume of the data is increased by your home gadgets. And take my words, whatever the infrastructure being deployed by top IT companies, that is required now in your campus, and then further it is required in your particular departments. And why not for each individual who is creating a data 24/7 from your mobiles, or by using apps and many gadgets and all that. See the volume of data. Try and understand what is this challenge. And to store, you talk about blockchains. We talk about big data architecture. In big data, you talk about Hadoop, HDFS. Google use GFS, and many other. In the recent scenario, one of the PhD awarded to one of the scholar, and we proposed a new model. I basically implemented a new file system architecture. So what is that? Ultra compression techniques to introduce in the new file system architecture. That means I'll just give you a layman answer. In 2 GB pen drive, I give you a guarantee I can store 2 exabyte of data. 2 exabyte, even not petabyte. So I think KB, MB, GB, TB, PB, and then EB, exabytes. So I'm talking about 2 exabytes you can store in 2 GB. Ultra compression technique. This is what we claimed, and we are very soon on this particular, and we deployed in certain pen drive and some device and some connectivity and all. In that case also we use the concept of edge. So security privacy is a fog. Yes, I'll come, and obviously this is a best practice because you need more security. So fog will give you more security than even cloud, because AIMS database hacked. I hope you remember that. You remember that Aadhaar database multiple times being compromised from the various. Actually, Aadhaar was hacked by the fog or providers or the edge providers. Aadhaar server never being hacked, but yes, AIMS Delhi database was hacked by their servers. So if you will keep it centralized, this is not a good practice. Today we want a distributed architecture. We have to work on various different layers. So at which layer data security works? Data security need to be work on all the layers, starting from the application point of view and up to the channel level, right? You can take it OSI, all 7 layers, the security is required because your data exists on these all different layers. And I would like to show you some practicals with the connectivity of edge. So that is what my purpose is. I would like to show you that particular part. Quickly, I'll come to that. So what is the part? Let us try to create some isolated environment like in IT department. If you are from IT or computer science department, let's say I'll keep only the data of computer science department. So it's like a fog network. You have a HOD of that particular department. That means he is the handler of that fog. You can just try and consider it like this. So this is the way how it is working. And each professor who is taking care of their sessions is basically not a fog. They are nested to the fog, and that is basically acting like an edge computing. So as I think at the beginning, Professor Neha said very correctly, we are very near to sensors. So what is very near to sensors? Now I'll talk about this particular part. So this is the foundation of edge, how it was started. And today, edge has been converted to different level. Today, we want the edge in the different perspective. We change the framework of the usage of the edge. So evolution of the cloud to fog and fog to edge computing model. So I hope you know IIoT, that is industrial IoTs, data processing and layer stacks. So you have a cloud layer, and on the cloud layer, you can talk about big data handling, business logics, data warehouse where you keep all the data, and you talk about the business and analytics or business intelligence, or today why don't we incorporate ML, AI and many more things, and obviously security, then optimization, challenge, clustering, load balancers, dynamic load balancers, especially function as a service is one of the part, and elasticity is the part of the cloud layers and cloud computing. That is one of the area where you can explore. Further, we have a nested data flow model. So we have a fog layer, so local networks. That is what in the fog we are talking about, local networks. We are talking about data analytics and the reduction, control responses, virtualization and the standardizations of the various different aspects of each fog at different stages. But that is not enough. We need to be more elaborative. We have to go more into the depth of edge layer. So edge layer is to be on certain, could be an application, a large volume of the real-time data processing. So to handle real-time data processing in the case of edge, we are supposed to talk about certain application at the source, on the premises, data visualization, industrial PCs, embedded systems, gateways. I talk about IIoT or IoT gateways, and why not micro level data storage models, which is the one of the part of it. And finally, you have a lot of sensors and controllers, which is there. In fact, anybody heard about one more technology called mist computing? Anybody heard about mist computing? One is cloud, fog, edge, and one more technology is mist, MIST, mist computing. Anybody heard about mist? So I'll tell you what, mist is basically even between sensors and edge is kind of a mist computing. Means more closer to the kernel of their sensors. So it is actually somewhere with the connected with the sensor in your Raspberries and all, because today the data being created in the various different part, and if you talk about any particular protocol have a lot of parameters. If there are a lot of parameters, can we collect only the limited level of data set or the limited level of parameters, so that we can only consider that for the analytical purpose and all. So today, I hope if you are aware of ML AI, what is the culture? Today's the culture is today your culture is what, like everybody is behind a data set. Today it's a data era. Everybody is behind data. If you are working on machine learning and artificial intelligence, it very clearly said the more size of the data you have, the accuracy is more, because that accuracy is to be filtered and average and all that, multi-model LLM models, large language models being designed, especially in AI and ML, and you design that particular part at your stage. And out of that, if we'll try to correlate with the test cases, we'll get more accuracy. So for more accuracy, you want more data. This is what ML people are running behind it. No. Take a halt. In case of edge computing, we have to do reversal. In edge computing, it is not similar to AI ML. We have to do something reversal. Reversal in the sense, anybody heard about like business analytics for the manager? Especially I'm talking from now the management perspective. According to the management perspective, there are 5 different stages, and data warehouse comes on to the last stage. The top stage is strategic level, means all top notch people who are working on the strategic level. The second stage is like CEO, CTO, and the operation, basically the decision maker authorities on the second level. On the third stage, there is a data analytics people. On the fourth stage, we have IT people. And on the fifth stage, we have a data warehouse people. So that means now what we need to do, especially in IoT, because the volume of data is very high. So obviously, you cannot go with supervised learning according to ML. We have to go with the unsupervised data set. If we are working with the unsupervised data set in machine learning model or with AI model, try and understand, we can able to cater the lot of data or categorical data, or we can able to cater various different stages of the data and some collection of data. And on that, we can go for classifications, algorithms, we can go various other algorithms on that particular part. But at this stage, you have more data and then you create a result? No. In case of edge, because volume is very high, you cannot able to store, you cannot able to manage. Let us do the reversal model. What is the reversal model? This is real-time practicals which we are doing. We'll discuss with the strategic discussions. We'll talk and sit with them. We'll freeze what all the queries you want to run in your business analytical model, and accordingly, you give us the detail. We'll decide the level of parameters which we are required, and based on parameters only and only will generate the data set for those parameters. Rest will ignore. Even probably you heard about, like, if you are going to generate your models and you want to compare a lot of models, probably you are doing regression, you are doing logistic regression or various other regressions, or SVM or random forest or decision tree. I think if you are already on these algorithms, so you further going to compare it and find which algorithm is better for your research work. This is quite common practice. I think you must have seen. What my part is, no, don't go in this way. For your research, for all the faculties, start from the strategic level. Top level will give you the decision what all the parameters are required and what type of queries you want to execute on the big data model, on the real-time data analysis. Then only you can handle real-time data, otherwise not. We don't have a storage. If we'll make a storage up to petabytes, I think that could be somewhere probably another decade or somewhere another way how we can manage, or otherwise you must have a good budget. Because in India, that is a big problem. We don't have budget and we want everything. That's a very, very common problem for everybody. So try and understand, within a budget, we are not going to create a data for everything. What we need to do, will only take those parameters which are required for our business analytics algorithms, and will only process the data onto that and will collect. So we are trying to reduce the data set. We are trying to work out on the real-time analysis, and that is the best practice to cater that data. And then only you are going to create a corpus, and corpus to be from the edge perspective, not from the fog or not from the cloud and all that stuff. So think from the edge perspective so that you can able to generate the data. And even within the edge, we have to deploy some mist computing, embedded firmwares in the sensors. And again, within the sensor, you don't have memory. Memory is the major challenge. So think about, can you customize the packets, network packets? Can you work on that model? So the problem with the cloud computing, what are the real-time challenges? It's a centralized model. We don't want centralized model. It's a very high latency. Bandwidth congestion is another problem. Privacy risk is another problem. Dependence on a stable internet connectivity is another problem. Instead of that, probably you can go with the nested part, that is a fog computing. So if you are on the fog computing, you can talk about smart city traffic controllers, you can talk about smart grids, substations, you can talk about industrial PLCs or SCADA edge aggregators. You know data aggregation? What is data aggregation? Let's say I have 1 lakh sensors, so sensors are generating some data or even some logs being created because they did certain activities, so there are certain logs being created. I need to cater all the logs from the various IoTs or IIoTs, and I want to make it an aggregated data set, and then we'll try to transform that data set, normalize that data set, we'll do sanitization of the data, and so basically it is called as a automated tri-edge data set. So I'm talking about automated tri-edge data set. What does it mean? It means you did a sorting, everything being committed, and now your data set is quite accurate. So if you have that level of data set on the fog level, you can work on it. But no, it is not good to go in case of edge. Now, if you go and talk about edge, we are working on the low level, ultra low level latency, and we want to reduce the cloud dependencies architecture, efficient for the real-time analysis. But from that particular perspective, from that, let's say from one classroom in your college, I'm not talking about HOD level, fog level. I'm talking from the classroom level. I'm talking from the faculty level. So think on that ground. So you are basically connected with the edge to edge. And if you talk about subject level, that is mist level computing. So you can take it in the hierarchy in such a way that not only 3 stages, think about 4 stages, or even we want more stages. Then only you can able to handle that data, and you can talk about analytic on the real-time basis. Otherwise, it is very difficult with the existing models. So try and understand what is this all about and what are the characteristics of the edge. So proximity of the data sources, processing occurs within the milliseconds. That is what I told you. We have a low latency, which is a good part. So it is quite good for transportation, healthcare, robotics, and safety critical applications. Think about bandwidth efficiency. So only filtered or aggregated data is to be transferred. Filtered and aggregated. We don't want to generate every huge data and AI ML will process it. No, we have to filter the data. We want aggregated data and filtered data. Contextual awareness. So edge devices know their environment, their location, time, sensors, context, etc. That is very important because, and again, the best part, means if I'll ask you, how can you recognize any IoT device? Which IoT device generated what? And suppose there is any anomaly behavior being committed by any sensor, or probably any sensor got hacked due to any reasons. How you will manage it? How you will identify it? So basically, we have to go with the anomaly detection techniques. There is an algorithm called anomaly detection techniques, and you can apply. Even deep fake videos are there these days. You can understand if you talk about from the camera point of view, from social media, we can collect the data. So data is everywhere. Problem is what we want to, extract, what we have to, process, what are our goals. Accordingly, we need to decide. So location, can you give a geolocation, latitude, longitude into it? Or what about a device host ID? Now think practically, your device have a MAC address and MAC address is of 48 bits. Can you incorporate in IoTs? Are you ready to take a 48 bits of just in the header of the data set, where you are carrying a 48 bits, let's say MAC address, for the unique identity of that data set, of that particular device, and then you have 1 lakh. So what would be the volume? No, that's not a good research practice. We have to reduce. We have to go untrusted devices. We are talking about C2C model. This is, consumers to consumers are interacting to each another. Think like that. It's a mess of data. So out of it, we need to figure out the real-time traffic, the real-time analytical part, the real-time model. So what is the best practice? We'll talk about certain protocols on this ground, right? I would like to show you. So this is one of the wonderful part. I think you can understand with this figure. I try to talk about the features. So let's say top four features if we'll talk, and comparing with the cloud, fog, and edge. So in case of cloud, we have a high milliseconds, 100 to 500 milliseconds latency, very high. In case of fog, it is being tested generally 20 to 50 milliseconds. And in case of edge, ultra low, that is 1 to 10 milliseconds. And I have shown you right away, Google output for one ICMP protocol packet of 32 bytes would be, accomplish that task to transfer the packet in 5 to 7 milliseconds, which means very clearly, presently, Google is working with the edge technology. And quickly, even you can test right away, if you want, you can test. Please, everybody, you can try and ping to Google if you can. And anyone, I think one or two, or volunteers are there, or some research scholars are there, and they're really willing to go for it, and they can check at least. I'll quickly show you again back to this. 7 milliseconds. But what is the IP address? And because we are in Pan India, we are connected. I think that is the best practice. People from South India, North India, East India, West Side India, or Central India, please try and ping to Google. You might get the first two values same. According to, you can take it as a class B IP addresses. Is it first two values are same and rest two might change? So that means they have a pool of IPs and they are basically working with their fog or edge level. And as I'm in Delhi presently, I try to ping to Google, and one of the edge server of the google.com replied back to me, and that is why the time frame is somewhere 7 milliseconds. So can you check what is your IP? This is my IP. I quickly even copy this. I'll just copy this and let me paste it on the chat. Can anyone quickly paste your IP? If you ping to Google, can you check what is your IP? This is the Google. I just try to ping on google.com, and that is what my IP is all about. This is my IP. What about others? Anyone can ping and just check. Is it the same IP or you have a different IP? No, this is IPv6. Please. Okay, for you, I'll give you the way what you need to do. You have to write this command, ping-4 space google.com. Just try this command. I have just written a command for you. See, Professor Ritinder Kaur, just take a look. First two addresses are same and rest two are different. So class B network. Can you see? We all are trying to ping to Google only, and your rest two IP addresses are different. Professor Bhavani, please use a command as I said, ping space -4. -4 is for IPv4. Your result is actually from IPv6. Just try and correlate and just check, and then you will realize what I'm talking all about. Understood? And see, Professor Neha also gave us the detail. See, the IP is completely different. Even I think Professor Neha, you are from Delhi, right? I hope you are from Delhi.
Yes, sir. I'm your anchor too.
Oh, great. Thank you. So you are in Delhi, I'm in Delhi, but your edge IP is different and my edge IP is different. I think you can see, and we all are trying to connect with the Google. So understood how Google is working in the edge layer and what is the speed and the performance being received by this. It is in 7 milliseconds or 6 milliseconds, depending upon also your bandwidth, whatever internet bandwidth you have. So probably it may vary. For every packet it is varying, say 6 milliseconds, 7 milliseconds or 8 milliseconds, depending upon your service providers and your services. But generally it is on the very, very lower side. And actually it is somewhere connected to the ultra low millisecond model, that is 1 to 10 milliseconds. So understood what is the latency period? And then if we'll talk about edge, think practically how Google has designed their framework, their infrastructure. If it is a cloud, we'll talk it like it is a cloud, then hardware level it must be a centralized servers, or if it is a fog, could be a regional server, and if it is an edge, on device or the gateway nodes. So is there any gateway node available for my ISP like I have presently on Airtel or any other ISP, and your ISP is on their gateway? Did Google deploy their hardwares to give you the ultra low latency part of like 7 milliseconds or 8 milliseconds? Can you create that level of network? And think about, so the speed latency is a one part, and otherwise you cannot see cricket match on your televisions with 25 crore people over there. How you will manage? Think the real-time issues. So heavy computing storage in case use case sustainability or suitability if we'll talk about. So again, heavy computing storage is required on the cloud. But in case of fog, we can talk about the aggregation of the data, buffering from the various different locations. And in case of edge, we are talking about real-time decision-making model. So understood what is the real purpose of edge and why it is to be compared with the cloud, fog, or edge. And even if I'll go to the mist, the response must be more faster, more reliable, but less data size, even compared to edge. So think on those grounds, right? And internet dependency is obviously very high for the cloud, for the fog medium, and for the edge is quite low. So I hope this slide is quite I think now you are quite easy to understand, and quite you are able to analyze what I'm talking all about. So some real-time edge computing models like autonomous vehicles. Do you have one of my research you can find, and I have one patent also on an obstacle detection technique in Australia, and one of my scholar who also awarded as a PhD, and we worked on a smart car systems, and we tried to incorporate all these theses and dissertations are available on Shodhganga. Even you can write my name on Shodhganga. You can download 5 theses are available of the students where I was a main guide, and the research has been already committed. So you can analyze what I'm talking all about, right? So autonomous vehicles, car generated one per day, 4 to 5 TB of the sensor data being generated by your cars, your vehicles. Edge processing enabled like collision detection, where the response should be less than 10 milliseconds. I think now you can understand. Is it possible by cloud? No. 500 milliseconds में तो accident हो जाएगा. It's very quite often. And if your internet is not up to that mark in the car, I hope that is prone to be for the disaster. Lane detection, object detection. So we want edge. See the edges nowadays in our surrounding. We are on edge. And vehicle to vehicle communication. So peer-to-peer communication, client-to-client communication, vehicle-to-vehicle communication. One vehicle is having some data set, and we have to maintain, let's say, the distance between one vehicle to another vehicle. Really want to transfer a data to some other fog or edge or somewhere? Why not one vehicle simply connect with the other vehicle with the concept of mist or edge? You can say with even edge also, right? So vehicle-to-vehicle communication. Think on that particular perspective. But now the problem is again back. To handle such a huge data, your CPUs are not enough. CPUs are not enough. So probably you go for GPU. Even, do you know, for especially for neural networks, there is a library in the Python called TensorFlow. And TensorFlow, obviously, I'll show you the code even you want how I defined and configure that my TensorFlow library works on CPU. Do not go and try to identify the GPUs, because by default they try to identify the GPUs. Okay, gaming processing units or graphical processing units, which you can say. Why gaming? Because mostly people in gaming, they want a high FPS, and that is why they take graphical processing units. But do you heard about TPUs? Did you heard about NPUs? TPU is nothing but the TensorFlow processing units. So for a specific task, for AI or ML and all these kind of things, you're getting a specific processors to handle, to process even that data. So hardware level is again with that particular concern. But in case of edge, we need less hardware, very low memory, quite actively, less data transmission, very, very low data transmission, and then we have to perform. This is what we have to do all about, right? So quickly, I'll give you one more part. I think time, I don't know what is the time, if it's left, and I'll show you some live practicals also. Okay, we have 15-20 good minutes, not more than that. Okay, then I will I think I'll share this PPT to all of you. Let me show you the real-time practicals, and then you realize what I'm all talking all about. Just quickly take a look. Yeah, so I think we got a reply, various replies, and I think you got my answer what I would like to say. Understood? We all are only going to ping to Google, and all the replies are different. That means it's a pool of clusters of IPs within the case of fog or edge level maintained by Google, and that is why my latency is very, very low. That is what the practical I have shown through ICMP protocol. But now let me try to manipulate ICMP protocol, because I want to show you with the another protocol, very, very important protocol. Even you can explore that protocol for IIoT or edge. Do you know how this architecture is working? How to manage that data set? Now let us try to freeze some size of the packets. Let us take a size of the packet of 15 bytes and the header size is only 2 bytes. So total 17 bytes, one packet for IoT or IIoTs in the case of edge. And for that, how to manage? There is a very specific protocol for real-time analysis. There is a very specific protocol that is called MQTT. What is the protocol? That is MQTT, message queuing telemetric, T for transport. That is message queuing telemetric transport, MQTT protocol. Even you can explore. Let me show you right away. Why not? I'll quickly show you. I think you can see my screen, and I think you can also do the practicals at the same time. Just go and write how MQTT works. Let's say if I'll write MQTT works, I think you can go and check the Google. One small, very blur, but I think it's a video, but I think that is still better. There is a device generates some data, let's say temperature or something. That data goes to the publish model. So MQTT is not a three-way handshake like ICMP or your TCP, or even in case of ICMP, the size of the packet is quite high. Now, what is MQTT? MQTT, each device which is on the MQTT, they'll send the data to the MQTT broker side. And broker is nothing where they are trying to collect the information. It is a model called as publishing subscribe model. What is the publishing? It means if there are sensors, their job is to publish the data. Publish everywhere, just go and publish the data. But what about other sensors if they want to go for a like vehicle to vehicle or so they want any particular category of that? So basically what is it? Okay, let's try to, I'll give you a very layman example. I hope you all are comfortable in WhatsApp. What is WhatsApp? WhatsApp, take it WhatsApp like C2C model. All clients can able to communicate with any other client, right? And if now you know the groups, so group is just like take it as a topic, or even every message consider it as a topic. So one user generate a message from the WhatsApp, will consider it as a keyword called topic, and that topic get published. And once that topic published, any other user wants to subscribe to that topic. So frequently, one time you need to suppose subscribe, and then frequently you start receiving all the packets. So today you are the member of many WhatsApp groups, and if one person plays the data which get broadcasted to that particular group. So MQTT protocol is basically this is what message queuing telemetry transport protocol works on the publish subscribe model. So either it publish, or subscribe means start receiving automatically. The best part, none of the device know what they are generating and for whom. So this is the practical part, and using the central servers, which is called nothing but the broker. So we need an edge server. Which is nothing but MQTT broker, right? There we have an MQTT broker server, which decouple the device client for efficient, lightweight communication, idle for IoT devices. This is what which is required. So device either publish, that is send messages about the specific topic, or subscribe to particular topic to receive the messages for that particular part. And that is why your Google Maps is working. How Google get to know that how many cars are there and if there is a traffic, and how real time they will give you the traffic details. One, obstacle detection technique. One car is there and you have another car, and the distance between each car, that we have to place a brake. Otherwise, that could be an accident. So for that, the distance is less and the latency must be low, and the data size must be very low. So basically in MQTT, the header of the MQTT is only of 2 bytes, and the packet size is of 15 bytes. So total 17 bytes released by MQTT. Are you getting my point? What is the way? What is the best practice of the how to handle the real-time data and all, right? Is that clear? So you can see, I think all the details are what is decoupling, what is lightweight, what is reliability, security challenges, and the best part, your MQTT supports SSL, TLS, right? And authentications. All digital certificates is again mapped with the, so security automatically comes into the communication. That means the data which is on the network layer between edge to edge or between device to device, is under SSL TLS model, transport layer security SSL layers, so which is the good part. But the model says that one person who published the data and that published data being transferred to all the clients who have already subscribed to that particular topic. This is how MQTT is working. Understood what is this criteria all about? And again, you have a QoS model, quality of services level, that is 0, 1, 2, and all that. You can go and try and you can find it out. So this is what my concern is. Now, if MQTT is working just like this, shall I show you something practical? This is one of my project in the forensics. Actually, I'm a consultant and investigator for my various law enforcement agencies. So as in the introduction, they have already explained, I'm with the ministries, Ministry of HRD, Ministry of Home Affairs, Ministry of IT. Today, luckily, 15 plus scientists working under certain were my student, and 6 plus scientists working in DRDO were my. So I produce scientists for Government of India. This is how I would like to, in a very short words, this is the way how I introduce myself. So in my research and these kind of research, if you'll talk about these areas, I have one forensics investigation model. Now, if any device get compromised within, let's say, MQTT or in any IoT architecture, there are some other couple of protocols are also there for real-time analysis. Okay, for especially for edge and edge-based computing and all. So if we need to figure it out, so how can you figure it out? Because the data flow is very high, volume is very, very high, right? You cannot manage, you cannot store even permanently. Only whatever is required. It is just like a sea, and within a sea, you have to go and identify your gold ring from the sea. The way you have to just identify a very, very, micro objects from the sea. This is like, and for use for the analytical purpose and all that stuff. So I want very relevant. I want least parametric part. I want, in other way, we used to call it headless protocols. Can we create a headless protocol? Can you think about it? See, I'll show you quickly. I'll show you. In the ping command, practically again, just take a look. Can I customize the data packet? By default, the size of the packet is 64 bytes. Can I customize it? Can you reduce the packet size? See, I'll quickly show you something. Ping, I have an option called -s, and I want only 1 byte data packet, 1 byte data packet to google.com. Now I'm generating a packet like this. Just take a look. The moment I'll press enter, can you see? Just take a look. If I'll generate this packet 1 byte, 1 single byte, I want a packet of 1 byte, but technically the bytes are 9 bytes. Why 9 bytes? 9 byte means 8 bytes for the header and 1 byte of data. A 1 byte could be a zeros or ones. You can take it like this because sensors generate a data like zeros and ones, and every particular millisecond or second you are generating and hitting a data, publishing a data. I think in MQTT you have understood that part. So I have a header which is of 8 bytes. Can be reduced. So MQTT is better than ICMP if I'll correlate and compare with these kind of protocols. And in this particular scenario, you can understand my header of MQTT is only of 2 bytes, which is in other way we call this a headless protocols. It's headless, but the size of the packet is somewhere like 15 bytes. Now again, even you compare 15 bytes multiply by 1 lakh. So earlier, for your answer, in this case, it is 64 lakh. In case of Windows, you can say 32 lakh, or we can customize. So why not? 1 byte means 1 lakh, but again the header is there, so 9 lakh packet per second, 9 lakh bytes per second, right? Can we reduce? And how to manage it? So basically, and again we want why don't we place that data also onto the now another concept called blockchain? Have you heard about blockchain? Because billions of devices, not only now lakhs or in crore, let's say billion trillions of IoTs are working. It's a very high, dense, intensive, in case of devices, or the data volume has been increased. Billions, trillions of devices are there throughout our surrounding. And now we have to cater the data from the real-time analysis, and we need to capture that particular part. So I tried to manipulate this packet at this stage. Again, ICMP is not good because 9 bytes. So what I tried to create some prototype for the forensics perspective. Actually, I'm into forensics, so I created one web app, and that has been highly appreciated in various different areas. It is just a prototype. It's just a prototype. I would like to share a one small prototype part along with you quickly, so that you can understand what I am doing and what the area of research. Say presently, see, I have a one React. I did it in the React JavaScript, React. So I'll just go with that particular part, and now I'm into this folder. Yeah, perfect. I'm in this particular folder. So you can see I'll just start working. I'm starting from my local machine, one npm, and I'll start my one of the web-based application which I designed specially for edge forensics purpose. So this is the way I have just initiated, and I started. All what I need to do, I need to copy this, and I'll not start with this because I have something in a different frame. So quickly I'll show you in that particular scenario. Okay, let me take it. Yeah, okay, so just take a look. Wow. Now let me keep it somewhere at the bottom side. This is edge forensics console which I just created, and what I did, see how it works. I want one actor. Actor could be my system. Actor could be the name like sign off. Actor could be a machine detail, any ID. That could be a one actor. An actor would going to take some practical implementation of something. Let's say I have a screenshot of PNG file which I want to access. I have some log files, so sample logs and many more things are there. So now I'll show you from the bottom. There are presently, I created a concept of blockchain where I try to cater all the edge details and the activity, the behavior which is running on the edge details, and I just cater 16 blocks, 16 blocks from the blockchain model, and how it is started and initiated. Can you see from the bottom on? So first I am talking about timestamp. On 12th I started. The actor who performed, the actor is system, or you can define any ID in case if you want. So actor is system, and what is the action is triggered. So we need some payloads in case of hacking and all. We provide certain payloads, so certain activity need to be performed. So we'll take it as an action. So first is action, second is actor, we have third as a timestamp, and whenever this activity performed, we need to cater their block hash. So it is on the blockchain, and I tried to cater the block hash on this regard. So I got this block hash because it is initiated first time. Okay, do you know how this works? I'm talking about chain of custody of the ledgers in the edge computing and their activities. So practically I try to work on it based on your old concepts of, doubly linked list. Anybody heard about, I hope you all heard about doubly linked list. Singly linked list, you are going always forward. No, in this case, I am not going to cater anything in the forwarding part. What I am interested in, from where the packet comes from. So do you know, even this is the real-time problem with the law enforcement and WhatsApp. Today, anyone can create a fake videos, fake images, or some objectionable content posted by anyone, and it is viral, circulated on various groups and all. So let us say, being into investigation, we got a complaint. Consider, we got a complaint. The complaint is that, hey, this is objectionable content. And now we need to identify who is the originator of that content. But from where we start working, one of the person came to us, one of the action being committed on their side, and we'll try to trace their data, and we found that is objectionable. And now what we want, from where you received, so they will give me the message, sir, so and so person posted that data somewhere on that group, or personally somebody sent it to me. So I'll go and check that person, and that person say, come on, this is a forwarded message. I also did the same, forwarded. So in India we have 140 crore people, and the globe, I think you can understand. Is it visible to identify from where the content has been originated? Take my words, this your WhatsApp simply raised the hands, and they simply said no to the law enforcement agency that I cannot help you to retrieve that data. And that is why, means they have very clearly also said that we cannot, this end-to-end encryption, even WhatsApp cannot retrieve your data. Why they are promoting like this? Because they can't handle the volume of the data. So what we want from where the message has been originated. So you can see a new topic raised from any IoT out of 1 lakh or 10 lakh or 1 crore sensors or billions or trillions of sensors under a edge or under a fog, and one sensor generated data, let's say a new topic being raised. So I raised, you can consider these all log files are as a topic. I have a topics. I started working on the topics and processing those topics. Who process? So I have actor detail, I have action details. So for each activity, I just place it in the hash, because if it is on the blockchain, then nobody can delete the data, right? And you got a confirmation and with the integrity checks that yes, your data is available, and public ledgers, open ledgers, I think you can access. If you are quite aware with a blockchain, correlate with that and place it on your edge computing model onto it. And then so previous hash is 00000. That means this is the originator, or from this particular time frame, this particular part, a new blockchain being created, and that is the first node. You can consider, like in doubly linked list, you can consider as a first node, and there is no previous node, it's a null. So same thing is there, which I am trying to incorporate on the blockchain using doubly linked list model, and I try to make it a one web app using React. Understood how the things are working on the back end, what is the real technology I utilize. Afterwards, now another hit being occurred. What is this? Let's say there is a action is ingestion. What is ingestion? There I have a concept of ingestion. So it means you can go and even upload any particular file. If you want, choose a file, like I choose a PNG file, any activity, you can pass the data, you can write any CCTV data, any IoT data, anything, any comment, any content, right? So we have a ingestion sample log. So I try to click on certain ingestion sample logs. So these all are the sample logs, right? So all the sample logs being created, or multiple logs were there, and step by step, as whatever the activity being performed, you can read step by step the activities are there. Let's say now I will run something for you. Say I have any particular part and now I want to verify the content. I want to go for the analysis. So I have some payloads under this keywords, under this buttons. So if I'll click, some payload executes and some method executes, and they'll perform certain tasks. So if right now you can see there are only 16 blocks. I just clicked on the analysis. So you need to write the actor name. I think you can understand what is the role of actor name. Without that, you cannot skip. And let me see, I'll write out, even this is what actor name, you can write even sign off, or let's say system. So if I'll write, let's say system, this is just a prototype, okay? So if I'll write the name called system, and again I'll go back, and if I'll go and click to any log, any topic, and if I'll go and analyze it, the moment I analyze, you can see 17 blocks. Earlier it was 16 blocks. So now I got a 17 blocks running in front of me. So let me take you to the top. This is the 17th block on 16th at 1933:55. Actor system performed the analysis on the block hash, which is a new block hash being created at this stage. And what was the previous one? The previous one block is the block where I catered exactly in the today's afternoon at 12 p.m. 15 minutes, 13 minutes, 32 seconds, and you can see this block hash is exactly the same hash, right? This is exactly the same hash, and you can see this is the exactly same hash as the previous hash. Now, what is the data? What all the things are going on? Let me try to show you in the form of, like, let me export the report. So I got a report in the form of JSON file so that I can incorporate in any application or any analytical model. So I'll quickly like to show you what is this analytical part, and this is what right now what we have implemented. So can you see this? All the artifacts stored over there, and under this particular category or any particular category, if you will just go, this is the 16th or further blocks, right? If you just go and check, I have only 4 good variables: previous hash, artifact ID, actor, action, and with some metadata. Obviously metadata is there. So but what is there as a data? So as a data, there are only 4 values which are there: previous hash, artifact ID. So I reduced the data size and I created. So this is the way how I create a protocol. Anybody worked on how to create and design a protocols on edge? We want a new research area. I think that is what a direction I can give to all the researchers and the faculties. I try to incorporate only in the 4 parameters. So I have only 4 parameters where the size of the file is excuse me, 15 bytes only. Then file name is there, and some block hash and their details are there. So this is how the content which is working. I think I just got a call, we have to wind up, so give me a minute. I think yes, ma'am, I understood. I think that is that I need to wind up now, time is over. So please just give me a minute, I'll quickly do this. So I think you can understand the way how it is working. So we have a previous hash, artifact IDs, actors, and actions. This is what 4 parameters. 15 bytes, 2 bytes for headers. Think like that model. Even this is MQTT. This is not new model. This is MQTT which has already been designed. I want some researchers who can come and work on this kind of model, or think the way can you customize the new protocols with micro level in such a way that you reduce the parameters or reduce the size of the packets in the case of blockchain, so that whatever the data you want to cater, you just specifically pick that part of it and process and get your business results, analytical results. What is the way that flood is going on, but I have a particular topic, and from that particular topic I'm onto the edge, and from that edge I just need to identify what are the nearby edges to me, or device to device communication with me, and how can I handle that data, what all I am going to retrieve. My data is unique because I connected to various topics or different devices, and how you can identify. So there are, now I opened a one platform for all of you. Think about device uniqueness, and even do you know, we don't cater the device details, especially in case of edge. It is not possible. We can't talk about MAC IDs or other host IDs or IP addresses on that. No, not required. Please try and understand. We are taking open-ended, always zero trust network. Think about zero trust network and 0-day mitigations also for the high security process, and especially for the edge computing process. Think on that grounds. Try to cater, try to mitigate, try to manage with some security process. Think about clustering, think about load balancing, and whatever data generated, think about the distributed network architecture with their blockchain models, their signatures and data somewhere located, and then process. How to reduce the data size, right? And how you can make your new file system architecture, new protocols on that. I think I can help you if you are onto these kind of research, and if you are really interested to go and get into it. I have various suggestions and some practical areas. I think if you can just do this 80-90% your research part, I have already shared a one real research part with you on edge, the major challenges on edge, and how you can cater these problems. Let's say it is presently 15 bytes. Can we make it 13 bytes? If you just reduce with 2 bytes on edge, take my words, your PhD get awarded. You will get an extra PhD or whatever. This is what, like, the new research areas which you want, right? So many things are going on. Like in Walmart, you can see they have a Walmart Edge retail analysis and deployed on the various servers in their fourth. They are doing temperature monitoring for the freezers. They are doing product theft. If you go to any other country like in Singapore or US or other, there they don't have a people over there who are doing a billing and they're scanning your products. There's a self-scanning models are there. You just go and select the product which you want to buy, take it to the self-scanning machine, take your machine, scan your product. So over there you will get a bill, pay and move out. But due to intentionally or unintentionally you got one more product which has not been scanned over there. So the inventory management will quickly identify your behavior, and they'll immediately, within the fraction of minutes, the cops might be on that doorstep, and they'll ask you are carrying some extra product. See, this is edge. Next level. Privacy to bhul jao, abhi to bada alag hai. And we want compliance with the legal system also. That is again challenge. IT Act, DPDP Act. Think about BSA, Bharatiya Sakshar Adhiniyam 2023. If we'll talk about the legal perspective, and if I'll incorporate those with the system, with the new upcoming next gen models, that would create a problem for us. Yeah, thank you so much. I got another good call, Professor Prerna. Just give me a minute. Yes, hope. Yes, ma'am, I'm just about to wind up. Are you there? Hope you are listening. Okay, let's say I'll wind up because already I took 12 extra minutes in this session. So hope you enjoyed the session, and I'm open for the question answers in case, or I will share my details to all of you. And anybody who really willing to connect with me, I'll share my details. My name is Dr. Anup Girdhar, and you can find my mobile number. It's 9811485729. So you are most welcome. In case if you have any further queries related to your research work, I think I can help you in that. And otherwise, I'm through with the session, and hope you enjoyed with the real practical scenarios of edge, because otherwise it becomes monotonous or very theoretical. I don't want theoretical part, so I try to make it more practical oriented. Thank you so much, Professor Neha, and the entire team of WIPS, Professor Prerna, who shared the link, and all the dignities from WIPS and dignities off offline, and somehow they are connected to this online session where I cannot see to all of you. But thank you so much. Thank you. Session is over to you, to all the volunteers, or to the team of WIPS. Thank you so much.
Yes, your session was quite enriching. I was thoroughly enjoying it, and I wanted to learn more, but then due to time constraints, we are about to close. And again, definitely we'll be in touch, sir. And I would like to give you a thank you note. Thank you very much, sir, for delivering such an insightful and enriching session. Your deep expertise in evolution from cloud to fog to edge computing provided our participants with valuable knowledge and a truly engaging learning experience. Yet, I would request all the participants to please fill the attendance link, which is provided in your chat box. And I would request again all the participants to please on your camera so that we can have a photograph. So you're also please welcome for the photograph.
Sure.
Yes, sir. I think it's done. Thank you so much. Thank you, sir. Thank you for your work. Welcome.
Thank you.